In this video, we're going to implement items for our game, as well as laying the foundation for our inventory system. And if you haven't seen it already, Sebastian did the previous video on implementing the player character, so go to his channel and check that out. Other than that, let's get into it. So as you can see in the previous video, Sebastian set up this nice player character. Let's create an item here that he can pick up. Let's go to the hierarchy, right click, go 3D object and cube. This is going to be the temporary graphic for our object. Let's scale it down a bit and move it over. Let's also give this a more fancy material. Let's right click, go create material. Let's just call this material item. Let's drag it onto there and change the tint to a, say, shiny yellow. Now it looks like something we want to pick up. Let's now select the cube and rename it to test item. And let's now create a script that will allow us to pick this item up. To do that, we'll hit add component and we'll create a script called item pickup. We'll of course select C# and hit create and add. And now the thing about this script is that an item is an interactable. And so we don't want to write all the code for focusing an item, walking to it and interacting with it once again. Instead, we'll simply derive from interactable, which is the script we created in video 2. We can also delete our two methods and everything under system.collections. Now without adding any code here, if we just save this and select the item in Unity, we can see that we now have a radius and an interaction transform. That's because we've now inherited all the values and methods inside of our interactable class. Now one thing that's pretty annoying about our interactable in its current state is that we get a null reference exception until we go ahead and drag in a transform. I want to change this by just opening up the interactable, going to the bottom where we are drawing our gizmo, and in here I simply want to say that if interactable transform is equal to null, well then let's set interaction transform equal to our own transform. This will just make sure that we don't get any errors in the inspector. So if we now clear this and select our test item, you can see it automatically selects our own one and now the radius is displaying. But of course we do want to add a bit of extra code to our item pickup. The first thing we need to do is define what happens when we decide to interact with the object. And remember, inside of our interactable script, we created a virtual method for this exact purpose. So all we need to do is simply go into our item pickup and override this method. We'll write public override void and then interact. If you use autocomplete, it will automatically insert this base.interact call. This means that it goes back into our interactable and executes all the code inside of our interact method. We then add code before that or after that. Right now we only write out a message, but I'm still going to leave this in here in case we want to add more later. And after that, we can go ahead and pick up the item. So we'll call some kind of method here, which we'll call pick up. We'll then create this method, so void pickup. And in here we can start by writing out a message saying that we are picking up an item. Then we want to add our item to our inventory. And then finally remove our game object from the scene. So we'll just call destroy game object. If we now save this, go into Unity and hit play, you should see that when we right click to focus the item, we will walk over to it and pick it up. But we still need a way to define properties for our item. Currently there's not much to tweak here. We want to give our item a name, an icon. Later on with equipment, we want to modify stats on our player. So we need to define some kind of item data object. You could do that using some kind of data serialization format such as JSON or XML, or you could use a very handy feature in Unity called scriptable objects. Scriptable objects are basically custom assets that you can create inside of your project and then set properties for each object. In our case, we'll go ahead and create a C# script called item. This is going to act as the blueprint for all of our scriptable objects. So if we now open this up, we'll delete our two methods and our collection namespaces. And then we want to derive not from mono behavior, because we don't want this script to sit on a game object. Instead, we want to derive from scriptable object. And now we need to think about what all of our items is going to need. Remember, we're making a blueprint here. So all of our items is going to need a name, and we'll just default that to new item. You'll see a green line under the name here. That's because any object actually already has a property called name. And so there's a conflict when we also create one called name. You could go in here and put, say, item name, but instead I'm just going to put a new here in front of the variable, which means that we're going to be overriding the old definition and using this one instead. Then we'll also want an icon that will show up in our inventory. For that, we'll create a public sprite, call it icon and set it equal to null by default. And at some point, Sebastian is going to add some nice equipment to our character. When he does this, he's going to equip our character with some default wear. And when we replace that default wear, we don't necessarily want it cluttering up our inventory. So we'll just go in here and add a public boolean stating whether or not this is a default item. and we'll just set this equal to false by default. So now we've kind of sketched out what properties we want our item objects to have. Again, later we'll add equipment types, armor modifiers, damage modifiers, and so on, but these values will be shared by all items. But one thing we still need to do is tell Unity how we want to create new items. This can be done super easily by using an attribute. It's called the create asset menu. Here we can give our item a default file name. We'll just set it equal to new item and a menu name. This is where we're going to navigate in order to create our item. We'll put ours under inventory item. Now if we save our script, go into Unity, and then right click in our project panel, go create, we will see a new tab here called inventory, and under there we'll see an item. If we press this, a new object is created in our project panel. This is our scriptable objects. We can give this a name in the project. I'm just going to call it test item, and then we can fill out all of our variables. Let's call it the helmet of protection. We'll just leave the icon blank for now, and we don't want this to be a default item. And we can now go ahead and create as many items here as we want. In fact, let's go ahead and create a folder for all of our items. Let's drag our test item into there. So now all we need to do is link our test item with our item pickup script. To do that, let's open up item pickup. In here, let's create a public item, and let's just call it item. And now we can access all of the values under that item. If we write item dot, we can see both the icon, the default item, and the name right here. So instead of saying picking up item, let's say picking up and then followed by the name of the item. Let's save that, drag our test item into the item slot, hit play, and now when we pick up the item, it's going to say interacting with test item and then picking up helmet of protection. Awesome! So now we know what item we are picking up, but currently we're just making it disappear. What we really want to do is add it to some kind of inventory. To do that, let's create another C# script. Let's call it inventory. Let's also create an empty game object in our scene, reset the transform, and call it, say, game manager. Let's then drag it to the top so we can always see it. And here we want to add all of the scripts that control the general state of our game. I'm going to add my inventory here, but you could definitely also put it on the player. Let's open it up. And we do want to delete our two methods, but for this one, we'll keep all of the namespaces. And that's because we want access to the list type. Because central for any inventory is a list of items. So let's create a public list of type item. Let's call this list items and set it equal to a new list of items. Then we can create a method for adding a new item. Let's go public void add. And here we want to take in an item called, say, item. And we then simply want to add this item to the items list. To do that, we go items.add, and in here we put our item. We also want to make a method called remove. This is also going to take in an item. And you guessed it, this time we just want to go items.remove and then put in the item. There are a few cases where we don't want to add an item. Remember how we created our isDefaultItem variable? Well, this is where we want to take it into account. We don't want to go ahead and add this item if it's a default item. So in here we'll write if our item is not a default item, well then we want to go ahead and add it to our inventory. Of course, we also need to call these methods. Inside of our item pickup, we've already said that this is where we want to add the item to the inventory. But we need a reference to our inventory. We could just go find object of type, inventory, and then call the add method on whatever we find. But this is fairly taxing. Instead, what we'll do is go into our inventory, and here we'll create a very simple singleton pattern. Now this is not a video dedicated to singletons, so we won't be making a true singleton pattern. In fact, I'll just show you the easiest way at all to get this working. But hopefully, you'll get the idea. If you want to learn more about singletons, I'll have a link in the description. The first thing we'll do is create a public static. And this is where it becomes a bit weird. We'll create a public static inventory. That's why we're creating a variable with the same type as our class. We'll call this variable the instance. Then we'll make an awake method. And in here we'll set instance equal to this. So basically what we're doing here is we're creating a static variable, meaning a variable that's shared by all instances of a class, and we're calling it instance. Then when starting the game, we are setting the instance equal to this particular component. That means that we'll always be able to access this particular inventory component by simply going inventory.instance. It also means that you should only have one inventory at all times. In fact, let's go ahead and write if instance is not equal to null. Well, then we want to warn ourselves because we've clearly done something wrong. So let's go debug.warning saying more than one instance of inventory found. and we then return out of this method. Now this piece of code can be pretty confusing to understand at first, but it's something that you will see on so many different scripts, especially scripts sitting on some kind of game manager. And since this part of the code is not really related to the purpose of the class, I like to hide it away at the top. To do that, we'll use a region. We'll call this region the singleton. And then at the end here, we'll use end region. That just means that we can take this entire piece of code and collapse it. It's always here, so we know it's using a singleton, but we don't have to look at the actual code. If we then save that and go into our item pickup, now instead of using find object of type, we can simply write inventory.instance, and there we go. We now have a reference to our inventory script. So now we can call add on that script. And the item that we want to add here is the item variable. Let's then save that, go into Unity and hit play. And if we have a look at our inventory script, it currently has no items. If we then pick up this item, it's going to say that we have one item, and the item is going to be our test item. Awesome. So that's the very foundation of our inventory. But there's still some common things that any inventory should have. The first thing is, of course, limited space. Let's go ahead and create a public integer called space and set it equal to, say, 20 slots. Then when trying to add a new item, we'll check if items.count is greater than or equal to our space variable. If it is, well then we want to debug.log that we don't have enough room, and then return out of the method. And if we get past this if statement, we do have enough room, and so we want to add the item. However, this is currently going to lead to a bug, because in the event that we don't have enough room, we don't want to consume the item. We want it to still sit in the scene. But inside of our item pickup, we destroy the game object regardless. We try and add the item, and whether it's successful or not, it's still going to destroy it. So what we'll do is go into our inventory and add a return type of bool. Here we're going to return false if we didn't pick up the item, and if we did, we're going to return true. Now we can save this and not use it at all. We don't have to worry about the return type, but in the case of picking it up, we definitely want to know whether or not we were successful. So we'll create a bool here called was picked up, and we'll set that equal to the result of our add method. We then check if the item was picked up, and if it was, we want to destroy our game object. Now if we go into Unity and try decreasing our space to say 2, we then duplicate our test item a few times. Let's play and let's try and pick some of these up. So the first time it gets added to our inventory, the second time it does so as well, but the third time it says picking up helmet of protection, not enough room. And as you can see, it hasn't been added to our inventory and it's not disappeared from our scene. If we were to go ahead and decrease the amount of items we have, well, now we can pick it up. In the next video, we're going to be displaying our inventory on screen. We'll also allow you to manage it by removing items and be using the same interface for later equipping them. But in order to update that UI, we want to know when the inventory has changed. In other words, when have we added or removed an item? To do that, we'll go into the inventory and we'll create what is called a delegate. A delegate is basically an event that you can subscribe different methods to. When you then trigger the event, all of the subscribed methods will be called. We'll create a public delegate, and you can actually return values in delegates as well. We'll just write void though. We'll call it on item changed. Then we want to open and close some parentheses and put a semicolon. Now we've defined our delegate type. Next we need to implement it. To do that, we create a public on item changed, and we'll call this our on item changed callback. Now if you've never seen a delegate before, this is a lot of weird syntax, but this allows us to do some really great stuff. Now we can have different methods subscribed to this event. We'll do that when creating our UI, but we already know when we want to call it. We of course want to do that when we add a new item. So after adding a new item, we'll go on item changed callback dot invoke. This means that we are triggering the event, and so we want our UI to update. When doing this, we want to make sure that we actually have some method subscribed to this callback. If not, we'll get an error. So we'll just make sure to check if onItemChangeCallback is not equal to null. And if it's not, well then we can go ahead and call invoke. We can just copy this code and paste it to the bottom of our remove function as well. So now whenever something is changing on our inventory, we are triggering on item changed callback. This is going to be super handy in the next episode. And that's it. The hardest part is actually done now. And we're getting pretty close to being able to add all of the cool stuff to our RPG. So I hope you'll hang in there. That's pretty much it for this video. If you enjoyed it, make sure to subscribe so you don't miss a future one. The next video on adding UI to our inventory should be out next Wednesday, so make sure to subscribe for that. Also remember, you can download both the environment and player character of dev assets, and if you get stuck at any point, you can download the project from GitHub. Both links are in the description. Other than that, thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in July, and a special thanks to Hans Hoftoon, Cole Cabral, Will Goat, Jesper Mikkelsen, Thomas Worley, Stone Gamer, Cyborg Mummy, Jason Latito, Derek Heemskirk, Faisal Marify, Robert Bund, and Peter Locke. If your name's not on the list, I will make sure to include you in videos later this month and the next month as well. Thanks a lot, guys!